Introducing OpenAI O3 and O4 Mini, our smartest and most capable models to date with full tool access. Today, we're releasing OpenAI O3 and O4 Mini, the latest in our O series of models trained to think for longer before responding. These are the smartest models we've released to date, representing a step change in ChatGPT's capabilities for everyone from curious users to advanced researchers. For the first time, our reasoning models can agentically use and combine every tool within ChatGPT. This includes searching the web, analyzing uploaded files and other data with Python, reasoning deeply about visual inputs, and even generating images. Critically, these models are trained to reason about when and how to use tools to produce detailed and thoughtful answers in the right output formats, typically in under a minute, to solve more complex problems. This allows them to tackle multifaceted questions more effectively, a step toward a more agentic ChatGPT that can independently execute tasks on your behalf. The combined power of state-of-the-art reasoning with full tool access translates into significantly stronger performance across academic benchmarks and real-world tasks, setting a new standard in both intelligence and usefulness. What's changed? OpenAI O3 is our most powerful reasoning model that pushes the frontier across coding, math, science, visual perception, and more. It sets a new SOTA on benchmarks including Codeforce's SWE bench, without building a custom model-specific scaffold, and MMMU. It's ideal for complex queries requiring multifaceted analysis and whose answers may not be immediately obvious. It performs especially strongly at visual tasks like analyzing images, charts, and graphics. In evaluations by external experts, O3 makes 20% fewer major errors than OpenAI O1 on difficult real-world tasks, especially excelling in areas like programming, business/consulting, and creative ideation. Early testers highlighted its analytical rigor as a thought partner and emphasized its ability to generate and critically evaluate novel hypotheses, particularly within biology, math, and engineering contexts. OpenAI O4 Mini is a smaller model optimized for fast, cost-efficient reasoning. It achieves remarkable performance for its size and cost, particularly in math, coding, and visual tasks. It is the best-performing benchmarked model on AIME 2024 and 2025. In expert evaluations, it also outperforms its predecessor O3 Mini on non-STEM tasks as well as domains like data science. Thanks to its efficiency, O4 Mini supports significantly higher usage limits than O3, making it a strong high-volume, high-throughput option for questions that benefit from reasoning. External expert evaluators rated both models as demonstrating improved instruction following and more useful, verifiable responses than their predecessors, thanks to improved intelligence and the inclusion of web sources. Compared to previous iterations of our reasoning models, these two models should also feel more natural and conversational, especially as they reference memory and past conversations to make responses more personalized and relevant. All models are evaluated at high reasoning effort settings, similar to variants like O4 Mini High in ChatGPT. Continuing to scale reinforcement learning. Throughout the development of OpenAI O3, we've observed that large-scale reinforcement learning exhibits the same more compute equals better performance trend observed in GPT series pre-training. By retracing the scaling path, this time in RL, we've pushed an additional order of magnitude in both training compute and inference time reasoning, yet still see clear performance gains, validating that the model's performance continues to improve the more they're allowed to think. At equal latency and cost with OpenAI O1, O3 delivers higher performance in ChatGPT, and we've validated that if we let it think longer, its performance keeps climbing. We also trained both models to use tools through reinforcement learning, teaching them not just how to use tools, but to reason about when to use them. Their ability to deploy tools based on desired outcomes makes them more capable in open-ended situations, particularly those involving visual reasoning and multi-step workflows. This improvement is reflected both in academic benchmarks and real-world tasks, as reported by early testers. Thinking with images. For the first time, these models can integrate images directly into their chain of thought. They don't just see an image, they think with it. This unlocks a new class of problem-solving that blends visual and textual reasoning, reflected in their state-of-the-art performance across multimodal benchmarks. People can upload a photo of a whiteboard, a textbook diagram, or a hand-drawn sketch, and the model can interpret it, even if the image is blurry, reversed, or low quality. With tool use, the models can manipulate images on the fly, rotating, zooming, or transforming them as part of their reasoning process. These models deliver best-in-class accuracy on visual perception tasks, enabling it to solve questions that were previously out of reach. Check out the Visual Reasoning Research blog to learn more. Toward agentic tool use, OpenAI O3 and O4 Mini have full access to tools within ChatGPT, as well as your own custom tools via function calling in the API. These models are trained to reason about how to solve problems, choosing when and how to use tools to produce detailed and thoughtful answers in the right output formats quickly, typically in under a minute. For example, a user might ask, how will summer energy usage in California compare to last year? The model can search the web for public utility data, write Python code to build a forecast, generate a graph or image, and explain the key factors behind the prediction, chaining together multiple tool calls. Reasoning allows the models to react and pivot as needed to information it encounters. For example, they can search the web multiple times with the help of search providers, look at results, and try new searches if they need more info. This flexible, strategic approach allows the models to tackle tasks that require access to up-to-date information beyond the model's built-in knowledge, extended reasoning, synthesis, and output generation across modalities. All examples were completed with OpenAI O3. OpenAI O3 gets the response correctly without using search, whereas O1 fails to deliver a correct response. OpenAI O3 and O4 Mini are the most intelligent models we have ever released, and they're also often more efficient than their predecessors, OpenAI O1 and O3 Mini. For example, on the 2025 AIME math competition, the cost-performance frontier for O3 strictly improves over O1, and similarly, O4 Mini's frontier strictly improves over O3 Mini. More generally, we expect that for most real-world usage, O3 and O4 Mini will also be both smarter and cheaper than O1 and O3 Mini, respectively. Safety. Each improvement in model capabilities warrants commensurate improvements to safety. For OpenAI O3 and O4 Mini, we completely rebuilt our safety training data, adding new refusal prompts in areas such as biological threats, biorisk, malware generation, and jailbreaks. This refreshed data has led O3 and O4 Mini to achieve strong performance on our internal refusal benchmarks, e.g., instruction hierarchy, jailbreaks. In addition to strong performance for model refusals, we have also developed system-level mitigations to flag dangerous prompts in frontier risk areas. Similar to our earlier work in image generation, we trained a reasoning LLM monitor which works from human-written and interpretable safety specifications. When applied to biorisk, this monitor successfully flagged 99% of conversations in our human red teaming campaign. We stress-tested both models with our most rigorous safety program to date. In accordance with our updated preparedness framework, we evaluated O3 and O4 Mini across the 3 tracked capability areas covered by the framework: biological and chemical, cybersecurity, and AI self-improvement. Based on the results of these evaluations, we have determined that both O3 and O4 Mini remain below the framework's high threshold in all 3 categories. We have published the detailed results from these evaluations in the accompanying system card. CodexCLI, Frontier Reasoning in the Terminal. We're also sharing a new experiment, CodexCLI, a lightweight coding agent you can run from your terminal. It works directly on your computer and is designed to maximize the reasoning capabilities of models like O3 and O4 Mini, with upcoming support for additional API models like GPT-4.1. You can get the benefits of multimodal reasoning from the command line by passing screenshots or low-fidelity sketches to the model, combined with access to your code locally. We think of it as a minimal interface to connect our models to users and their computers. CodexCLI is fully open source at github.com/openai/codex. Opens in a new window today. Alongside, we are launching a $1 million initiative to support projects using CodexCLI and OpenAI models. We will evaluate and accept applications for grants in increments of $25,000 in the form of API credits. Proposals can be submitted here. Access: ChatGPT Plus, Pro, and Team users will see O3, O4 Mini, and O4 Mini High in the model selector starting today, replacing O1, O3 Mini, and O3 Mini High. ChatGPT Enterprise and Edu users will gain access in 1 week. Free users can try O4 Mini by selecting Think in the Composer before submitting their query. Rate limits across all plans remain unchanged from the prior set of models. We expect to release OpenAI O3 Pro in a few weeks with full tool support. For now, Pro users can still access O1 Pro. Both O3 and O4 Mini are also available to developers today via the Chat Completions API and Responses API. Some developers will need to verify their organizations, opens in a new window, to access these models. The Responses API supports reasoning summaries, the ability to preserve reasoning tokens around function calls for better performance, and will soon support built-in tools like web search, file search, and code interpreter within the model's reasoning. To get started, explore our docs, opens in a new window, and stay tuned for more updates. What's next? Today's updates reflect the direction our models are heading in. We're converging the specialized reasoning capabilities of the O series with more of the natural conversational abilities and tool use of the GPT series. By unifying these strengths, our future models will support seamless, natural conversations alongside proactive tool use and advanced problem solving. Footnotes: Taubench eval numbers are averaged across 5 runs to reduce variance and run without any custom tools or prompting. We found Taubench retail rollouts are more prone to user model errors. Numbers in parentheses are run with GPT-4.1 as user model because it's significantly better than GPT-4o at instruction following. SWE Bench uses 256K max context length, which improves the solve rate for O4 Mini by about 3% and impacts O3's solve rate by less than 1%. We also exclude 23 samples that are not runnable on our internal infrastructure. When enabling browsing, the model can sometimes find exact answers online, for example, by reading blog posts with sample problems from a dataset. We mitigate concerns of the model cheating while browsing with 2 strategies. Block domains that we have observed the model cheating from in the past. Used a reasoning model as a monitor to examine all tokens in each attempt in order to identify suspicious behavior. Suspicious behavior is defined as a page, file, or snippet whose main purpose is to provide the exact answer to this specific question, e.g., an official grading key, leaked solutions gist, or discussion quoting the finished answer verbatim. Benign behavior is defined as any authoritative resource a diligent human might consult: documentation, manuals, scholarly papers, reputable articles, even if it incidentally contains the correct answer. Any attempts where the monitor deemed the rollout suspicious are counted as incorrect. Most samples failed by this check were problems whose exact solution was available on multiple internet sources unrelated to HLE. Finally, our evaluations with browsing may not be perfectly reproducible in the OpenAI API due to a difference in search engine backends between ChatGPT and the OpenAI API. These results are intended to be representative of the ChatGPT user experience, but depending on demand, the search configuration may change over time.